Now see the part 10 of ionic equilibrium. Ionic equilibrium. Right. So next sum is 18. So the buffer solution is prepared in which the concentration of ammonia is given. So NH3 concentration is given, that is equal to 0.30 molarity, and the concentration of NH4 plus concentration is given, that is 0.2 molarity. If the equilibrium constant Kb for the NH3 is given, Kb, that is 1.8 10 raised to minus of 5. What is the pH of this solution? So you have to find the pH of the solution. It is asked in 2011. So let's see the explanation. So as we know, right? So POH formula we know, that is pKb, right, plus log of concentration of salt by concentration of base, right? So pKb, that can be minus of log Kb plus log of concentration of salt by concentration of base, right? So now put the value of Kb minus log of 1.8 10 raised to of minus 5 plus log of concentration of salt is 0.2. So this comes under the category of salt, this part, right? So this is your salt. This is your base, right? So put the concentration value. So it will be 0.2 divided by 0.3. So it is coming out to be, so you can write this part as minus of log 1.8, right? And again will become minus, so log of 10 raised to minus 5, and this will be log of 2 minus log of 3. So log 2 is basically 0.3, so it will be 0.25, and this minus sign will multiply with this, so it will become minus of 5 log of 10 plus log 2 is 0.3, log 3 is 0.4. So after calculation you will get POH as 4.57, right? If you want to find the pH value, then you have to subtract the POH value. So it will be 14 minus POH is nothing but it is 4.57. So answer will be 9.43. So this will be the pH value. So please write it down. Now see the question number 19. What is the H plus ion concentration? So what is H plus ion concentration in concentration unit is mole per liter. It is already given there, right? Of solution, that is 0.2. So there is a solution whose concentration is given, that is 0.2 molarity in the acetic acid. So it is CH3CONA, right? And this is your sodium acetate given, sodium acetate. Next is acetic acid like CH3COH, and whose concentration is 0.1 molarity, right? So K for the equilibrium constant for this acetic acid is given, that is 1.8 into 10 raised to of minus 5, right? So you have to calculate the pH value. It is asked in 2010, right? See, so we know the because it is acidic buffer, you can see this is your acid, right? So acidic buffer solution pH can be calculated as by using the formula pH is equal to pKa plus log of salt by acid, right? pH is equal to minus log of Ka plus log of concentration of salt by concentration of acid. Now put the value minus log of Ka value we know that is 1.8, 1.8 10 raised to minus 5 plus log of salt value we know that is 0.2. It is already given here. You can see this is your salt. This is your salt. So whose concentration is 0.2. Now concentration of acid is given, right? So this is that is 0.1. So right here 0.1, right? So it will be what? It will be minus of log 1.8 minus log of 10 raised to of minus 5 plus log of 2 minus log of 1. Log 1 is 0. Now log 2 is nearly to 0. Log 2. So it will be minus of 0.3. And this minus 5 will multiply with this. Then it will become 5. And log 2 is 0.3. So it will be get cancelled. It is approximately answer is equal to 5.041. It is given. Right. So we have to find the pH. Now we have to find the H plus concentration. Right. We have got the pH value that is 5.01. So as we know the formula pH is equal to minus of log of H plus ion concentration. So it will be minus of log H plus ion concentration is, you have to find it, right? We know the pH value that is 5.041. So take this minus here, then it will become minus 5.041 equal to log of H plus ion concentration. Here base is 10, so it will be coming out 10 raised to minus of 5.041 equal to H plus ion concentration. Understood? So this will be the value. And if you want to write in approximate form, then it will be 9.0 into 10 raised to 6 mole per liter. So this will be the H plus ion concentration. Now see the next sum, that is 20. So what is in a buffer solution? It is talking about buffer solution. So buffer solution who resist its pH to change, right? It doesn't allow to change its pH. Doesn't allow to change its pH, right? So in a buffer solution containing equal concentration of B minus, so equal concentration of B minus equal to concentration of HB, right? And Kb for that value of B minus is given, that is 10 raised to minus of 10. pH of buffer solution you have to tell. It is asked in 20. So see the basic buffer solution formula. So this formula is for basic buffer. So POH is equal to pKb plus log of concentration of salt by concentration of base, right? So this is the basic buffer solution formula, and it is given by the scientist whose name is Henderson. Henderson. So remember the scientist name also. Someone, it can be asked, right? Name Henderson equation, right? So now we will use the value now. So it will become minus of log of Kb plus log of concentration of salt by base. Now put the value, then you will get minus of log Kb value given, that is, right? So this is your equilibrium constant of base, that is 10 raised to of minus 10 log of salt value and base value is same, right? Because this is your salt, this is your base, whose concentration are equal. Then both are equal in concentration, then it will get 1, right? And as we know, log 1 is 0. And this minus 10 will multiply this one. So it will be minus of 10 log of 10. So as we know, log 10 is 1. Then it will become minus into minus plus, right? So it will be your POH. So POH is equal to 10. Then we can easily get pH value. How? Because we know pH plus POH is equal to 14. How they are related. Now put the value of POH, that is 10, is equal to 14. So pH will become 14 minus of 10. Then it will be equal to 4. So this is your pH value. Power of hydrogen. So please write this one. Now see the question number 21. Ionization constant of ammonium hydroxide is given. Right. Ionization constant of ammonium hydroxide NH4OH is equal to 1.77 into 10 raised to of minus 5 at a temperature of 298 Kelvin. Hydrolysis constant of ammonium chloride. You have to find it. So hydrolysis constant of ammonium chloride NH4Cl. It is asked in 2009. So see how you can calculate. This is very important and learn about it. So ammonium hydroxide equilibrium constant is given, and when it dissociates it form NH4 plus OH minus, right? So as we know, equilibrium constant for this ammonium hydroxide is given, and it can be written as in the concentration form of NH4 plus into concentration of OH minus divided by concentration of NH4 OH. Kb value is given, that is 1.77, 10 raised to of minus 5. Right. Now see the hydrolysis of ammonium chloride. So NH4Cl when react with water, right? So as we know, H plus will dissociate in H plus OH minus, right? And ammonium chloride is NH4 plus and Cl minus. So this OH minus will be attracted here, and this H plus will go with this Cl minus. And it will form NH4OH plus HCl, right? Now see the next part, ionic equation. Next is ionic equation of ammonium plus. So NH4 plus is there, and when it react with water like H2O, it form. So it is nothing but H plus and OH minus. This OH minus will attract here. So it will become NH4OH, and H plus ion is there. So hydrolysis constant of this reaction can be written as Kh is equal to. So it will be the concentration of what? NH4OH, right? And H plus divided by NH4 plus. Now multiply and divide by OH minus. So what you will get? This equation, only this equation. So right here multiply and divide by OH minus concentration on numerator and denominator. Then your KH will become, I will write in the next page. So your KH will become now NH4OH concentration divided by NH4 plus OH minus concentration into H plus into OH minus, right? So now see, so your KH is now equal to, so you can see in the previous slide, so KB value is this one, right? So you can see here this NH4OH in the denominator part, right? So you take an the numerator, then it will be, so it will be 1 upon Kb, right? And this is your equilibrium constant of water. So it is equal to Kw, right? So Kw is nothing but it is ionic constant of water. So it is H plus into concentration of OH minus, right? So KH is equal to, we know Kw value, that is 10 raised to of minus 14, and Kb value is given, that is 1.77 into 10 raised to of minus 5, right? So it will be converted into 5.65 into 10 raised to of minus 10, that is equal to KH value. So this is your KH value. So please write it down how we have calculated. Now see the next term, that is 22. So 22 is, which of the following pair constitutes buffer, right? So it is asked in 2006. So C, first option is given, that is HNO2 nitrous acid. So it is a weak acid, weak acid, and sodium nitrate NaNO2 is there. So it is salt, right? So these two contribute to form acidic buffer solution, right? Because this is the combination of weak acid and salt. So it will form the acidic buffer, right? So option one will be there, right? It is asked in 2006. So write this one, then we will study 23. So let's see together 23. It is talking about H2S, hydrogen sulfide gas when passed through a solution containing HCl. So when H2S is passed through HCl, it forms the cations of second group of quantitative analysis, but doesn't belong to the fourth group, right? So it is second group, right? And it is doing the quantitative analysis. Quantitative, quantitative analysis, right? And it doesn't belongs to fourth group. So it is asked in 2005. So see the next explanation now. So when H2S dissociate, it forms in H plus plus HS minus, and it will dissociate two times, right? Why? Two hydrogen there is, hydrogen is there. So again, HS minus dissociate, it forms H plus plus H2 minus. It is in second step, right? So in the presence of HCl, HCl is also there, right? So this ionization of H2S is suppressed due to the presence of extra H plus. Right? When HCl will dissociate it from H plus plus Cl minus, right? And this is a strong acid H plus ion concentration. So this H H plus ion concentration will be suppressed due to the suppressed strong acid, right? So extra concentration of H plus will shift the equilibrium of H2S towards the left due to the common ion effect. So its concentration is shifted towards the left due to the H plus ion concentration increases. Shift to the left. Shift to the left due to common ion effect. Now see the next explanation. Hence the sulfide ion concentration become lower and group 2 cation have lower value of solubility. So right here, so sulfide ion This is your sulfide ion, right? So this will become, its concentration will be lower. So it will become lower and cation group 2 to cation having solubility less, right? So its solubility is also less, group 2, due to which they get precipitated. And while 4 cations have high value of solubility, so doesn't form PPT, right? So please write this explanation and join again.